Good morning. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India, addressing all my friends on globe on this day, April 25th, 2021, Sunday, another rest day, though there is no rest in world. Title of talk being Civil Field Engineering Designs, Construction Methods, Contracts, AnnexSL, organizations, communication, coordination, quality, quantity, etc., and somewhere a general talk about profession and life, and now what's happening with COVID-19. Well, I regret that what's happening very sadly in our country, and that is Bharat, India, happening unfortunately. COVID-19 thriving successfully, which it should not, but due to our own carelessness, our own lack of preparedness, it's working efficiently, super efficiently all over our country, areas, and also whole world is worried about that. Because until even one person is affected by COVID-19, no one can expect that COVID-19 shall go away. It was started to think on this in March 2020. How much did we think? How much did we do? That can be well said, well understood by state of COVID-19 currently in April 2021. Very big shot up in cases, up to 20%. Up to 20% individuals out of those being tested are recorded positive, COVID positive. This is very difficult situation. When it was 1.98, sometime less than 2% in January, and it is now 20% in April. In a 4 months period, 20% or around is very unpleasing, unbecoming situation. And if it continues, I think we have no answer to that. It's really very unfortunate that this has happened, this is happening. Being a citizen of this country, being a citizen of the world, is our duty to think about, though I'm talking about engineering and profession, well, I think there can be no living engineering if we do not think of COVID-19 now, because it is overwhelmingly defeating humanity, and not only in our country, it has defeated all over the world. It's a kind of force nobody expected 2 years back, 1 year back, 1.5 years back. But this force has come accidentally or unknowingly, like we consider forces or actions in our structural engineering. We take transient loading, persistent loading, temporary loading, accidental loading, like that we consider. What type of action it is? It is natural action, of course, but it can't be proved that this is natural. So much is involved with our own actions within this. So I will not talk at length about this in this talk, but just because it is happening at cost of lives, at risks of people, and risks which are moving very fast. We have no solutions. Risk means we have our own artificial risks, that we are not able to protect life of people due to absence of oxygen or absence of so many other requirements. We have to be very careful about this issue. Every citizen of this country is responsible, and those who are intellectuals, particularly engineers, because doctors are doing their job because there are two people only in every country, that is engineer and doctor, who make a country. Doctor takes care of health of people, health of community, while engineer takes care of development of nation. Development and nation, developing a nation and taking care of health, these are two important factors. If health is not done, health is not taken care of, existence of society shall be very impossible. Same way, if development is not taken care of, if we don't develop, there will be no existence of nation. So these two professions, these two intellectuals do have high level of importance, but it is unfortunate that I am not finding developers or engineers who even talk of COVID-19. I see on forum of structural engineers, I see on Facebook, I see on other many forums that there is no initiative on part of that community which is parallel to doctors, and they take care of development. They are only busy in their own profession. They don't have any 2 hours time a day just to think of, just to write something about COVID-19 and about public health care or community, war level or emergency services. They can teach people, they can understand, they can analyze, they can write something in interest of people of this country. But it is not happening, unfortunately it is. I'm not saying only I am doing, maybe I am wrong. There may be people working, but I have not seen such input on social forums, social websites, internet, or somewhere else. I don't know. Maybe I am wrong. I'll be happy if I am proved wrong. I have written many times also on this issue, but I think people don't even like to read that. I put my URL sometime on my postings on Safi, but I am not sure what happens. Profession shall work only, our jobs shall work only if people are alive, if country is healthy. If country is not healthy, people keep on dying, people keep on suffering because of COVID-19 or such virus. And what shall we do? I have no answer. Today situation is very grim, very serious. Around 2 crore people are already infected officially, but I don't agree with that. Around 200,000 people have lost their lives, but it's more than that. I don't agree with government figures, but because these are official, we have to refer to them. Reports are coming in from various sources, various reliable sources, that the speed of COVID-19 spread is going to be heavily increased in coming times. Some say in May it will be 500,000 per day infections cases. Some say it is up to 800,000 per day. It's very grim figure. It is, yes. Now it is about 20% projections of cases of those tested every day. If we take care of that, let us say 20%, we have total population of 130 crores, and 20% if you can vary 26 crores or 25 crores or 250 millions. That point we should not forget, that we are standing in very problematic state of COVID, and there is no solution so far. On news you might have seen what's happening of oxygen, what's happening to distribution system, what's happening to beds in hospital, what's happening to all ventilators, and what's happening everywhere. There is no satisfaction of any facility being extended to people. It may be government hospital, or it may be private hospital, or it may be at home. It's very, very serious issue. We have to think of this and find something. I'm not saying engineers would do it, but engineers have to think, they have to advise people. People have become careless because governments have become careless. When I say governments, means our national government and our state governments. Everybody has been careless. Last year, if you refer to March 2020, and now it is April 2021, 13 months have elapsed. What did we prepare? It's not seen, it's not evidenced. We have not seen anything that we did this much in 12 months to 13 months, what we did I can't say as an engineer. We did nothing. Only about 20 to 21% people have been tested so far in 12 months or 13 months. A shame. It's a shameful situation on our part. If we can't test 20, more than 21 people, more than 25% people, more than 50% people, more than 75% people in a year time, what can we do? What's our performance level? Testing is not going to stay. You have to construct some building. You can't say that. It's just a test. If a nation cannot test its people in 1 year, what shall we do? I have no answer. Strongly speaking, very heavily speaking, I can say we are not doing our job, we are not doing our responsibility towards COVID-19 effect on people. It takes 1 year to test 20 of these people. Means just 1 month we take about 1.5. Less than that or more than that. 1.5% people, so 5 times more. We need 5 times more time, means 4 years time. You need to test people 3 years or 4 years. Is it sensible? And until we know all people, whether they are negative or they are positive, we cannot say what state of this. So based on only, we can say, based on every day report, we can depend on that. And every day report says that now about 3.5 lakhs people are affected every day, and out of these people who are every day 3.5 lakh positive, and testing is about 14 lakhs, 15 lakhs. You can say about 20% people, 18% people, 19% people are projected COVID-19 positive. This may increase, I can't say, but it is expected according to statistics and about reports pouring in. I will go on higher profile. So we have to be very considerate as far as COVID-19 is concerned. Very serious issue, outstandingly serious. All countries have observed that because we are country second in population, and I already every day used to publish this very serious issue. You can see my Facebook postings, you can see my files on script.com. That issue is very serious. I did my best to alert public, but I think people did not read those Excel sheet reports and words. Well, it's up to people of this country, government of this country, what they think. I am very ordinary citizen. I am not a press person. I am nothing. Who shall read me? I don't know. But my conscience did not allow me not to do this. I did continuously and still doing that. But I think as a part of this country, citizen of this country, it's my duty to take part in such epidemics or pandemics, and this is a responsibility of everybody. It's a part of CPD, it is, because emergency duty is also related to CPD, continuous professional development progress. I'm not claiming that, but my mind says it's a must. If we don't have people, if we don't have nation in a good health, we can't develop anything. Then forget development, forget engineering, forget everything. If a nation who has 15 branches of engineering and have millions of engineers with it, and they don't care about such health issue, I have no answer to say, no response on this. I'm sorry to say. Engineering community should come up, but it's not coming up. They are busy only in their own techniques, in their codes or journals. They don't care about people of this country, and your journals, your engineering shall be of no use. If people are in problem, they remain in problem for years to come. And I'm sure coming 20 months are very, very critical for our country. Coming 20 months, I'm not saying 2 months, 20 months. All this 2021 and 2022, according to my assessment, this time is not good for our country, not easy for our country. So we must take care of COVID-19. If we don't take care of COVID-19, we will say that our whole life of social work has no quality system. It's also part of quality that we have to keep people healthy, physically as well as development wise. There will be no development if people are in problem, because there is no stability in country. There can be no funding for health. There can be no funding for development. If there is no funding for health and development, people shall suffer. There is no other way not to say no. I have no answer to say no, no or not no. I don't know, but I can only say that I can call it non-quality life. All other countries dealt with it. America dealt with it. England dealt with it. Europe dealt with it. Canada dealt with it. Venezuela dealt with it. And Brazil dealt with it. China dealt with this. Pakistan dealt with this. Australia dealt with this. And I think whole our world is a Gulf dealt with this. So we can say, because they have not that much population, America is having 33 crore population, but it dealt very badly. More than 600,000 people lost their lives. But our situation is going to be more than that. Still it is 180,000 of 200,000 loss of lives, you can say till now. But it may be 20 lakhs. It may be, you can say, 30 lakhs. It can go on in crores. If you don't worry about that. Yes, it can be. It can be in crores. It's not far away. Just like it is now around 2 crores. 2 crores cases, infection cases. This can be 20 crores one day. What shall you do? What shall I do? I don't know. Life is therefore, as we say, not that easy. We have to think of that, and we have to do that one. That's very important one. And if we don't do that, we shall be in problem always, every day, everywhere. We have to be very much worried about that. And I cancel that one. And what should I do? In this case, I can only say that you have to think of something. You have to think of something. You have to do something. And we have to be, of course, I may say that COVID-19 is not easy to go, but we have to take care ourselves. And I would speak to engineers only. Please, you are responsible people. You have to think of this issue, because everything is not in our hands, but efforts can be made. And I was talking of role of site engineer, whoever contributes to development on site and physical world is called site engineer. I talked at length yesterday on this issue. We talked at length about what is site engineer, what is supervision, and what is construction end. That issue we took care of. It's very long talk. And I was talking about soil report, which is very important document, very important work. Soil investigation report, which ordinary people in engineering do not value much, but it's very much important for me, for everybody. Soil investigation report. And at this moment, I would like to just share very old report it is, because it is a part of work, it's a part of knowledge. Whatever is available in field cannot be available in books, cannot be available in education. It was in May 2003, this report, about 18 years back, you can say. You must be happy that a report 18 years old I am sharing with you. it is because I worked there in that country that time, and I was a coordinator. You can say a kind of person who used to deal with all such issues. And this has certain chapters, like you can say what was purpose of a study, what was scope of work, and project description, site description, prevailing conditions, general geology of area, field exploration and testing, which is in testing itself, exploration itself. There is drilling. Drilling means there is sampling and borehole, sampling from boreholes, field testing in boreholes, excavation of trial pits, that's sampling from trial pits, field testing in trial pits, field density test, and there's soil electrical resistivity testing, field soil thermal resistivity testing, field soil thermal resistivity testing, and then we can say here laboratory testing, and that is laboratory tests and codes, then surface and subsurface conditions, ground materials physical, mechanical and thermal properties, materials chemical properties, sulfate content, chloride content, other chemical contents, oil and grease and hydrocarbons, pH value, and there could be groundwater in cavities. You can say here general discussions for choice of suitable foundations, and footings on sand, in that is general consideration of settlement, consideration of bearing capacity, choice of types of foundations, then conclusion, which is foundation depth and type, how to find that, tank foundations and hydrostatic testing, which is the available bearing pressure, foundation settlement, soil design parameters, foundation subject to vibrations, general consideration in designing dynamic basis, subgrade evaluation and pavement consideration, which objectives, method of analysis, subgrade properties, recommended type of pavement, general considerations, earth pressure parameters, site preparation, clearing and grabbing, cut and fill site, slopes, protection and monitoring, earth dikes and bumps, drainage, dewatering, excavation methoding, excavatability, excavation site slopes and lateral support system, and also backfill material and compaction criteria, structural fill and general fill. There are many other fills as well, but these are two important: structural fill and general fill. And borrow sources, soil resistivity and corrosivity, foundation concrete, tectonics of southeast region of peninsula, that's Arabic Peninsula, seismicity and earthquake area of southeast region of Arabian Peninsula, ground shaking and free field ground acceleration, liquefaction, densification, collapse potential, swelling and shrinkage potential, inspection during foundation excavation. And then there are certain figures, can say, that is major faults in southeast region of Arabian Peninsula, seismicity affecting southeast region of Arabian Peninsula, earthquake area in southeast region, average values of maximum acceleration in rocks. Then there are certain tables which give existing ground levels, plant coordinates, UTM coordinates and depth for all boreholes. Existing ground level, plant coordinates, UTM coordinates and excavated depth of trial pits. Proposed foundation level, foundation type and allowable bearing pressure, representative compression wave and shear wave velocities, summary of CBR and modified Proctor, earth pressure and soil parameters, soil corrosivity versus resistivity. And here is some appendix in this. Location of boreholes and trial pits means where these are located, coordinates, and also logs of boring and trial pits, legend to logs of boring and trial pits, logs of boring, logs of trial pits, generalized subsurface profiles, and field test results, field density test results, soil electrical resistivity test results, soil thermal resistivity test results, standard penetration test results, laboratory test results, grading curves, Atherberg limits and soil classification, moisture content test results, moisture density relationship test results, CBR test results, laboratory permeability test results, laboratory thermal resistivity test results, oil and grease test results, chemical test results for soil and groundwater. This is index of that. You can see a huge coverage has been taken, has been included in this soil report. You may not find all that in your soil engineering books. This is practical act, and you can say kind of thorough extraction of knowledge in this report. It's very important to read such reports for enhancing your knowledge, how work is done in field. This is much above than what you study in your university, because university won't give you this much chance or opportunity to know something, and this is where it has. Now, for example, it says in a scope of work here for this report, why this report was prepared, what was the reason, and what is scope of work in this case. The scope of works consists of followings, that is, collecting information in maps particular to site, such as public services, site plan, and land use maps. Collecting information it is. Making inspection visits to site to collect information about present and land use, surface topography, geological features, and surface drainage. Drilling total of 28, or it is 28 in this case, there can be whatever number, boreholes, and boreholes, you know very well what is boreholes, in situ testing and sampling of disturbed and undisturbed samples. Excavation of 3 number trial pits, can be whatever number depending on areas. Carrying out 14 field density tests, it can be whatever number field density tests. Carrying out 18 electrical resistivity tests with 0.75, 1.5 meter and 2.25 meter and 3 meter and 4.5 meter spacings, various spacings related, various spacing based electrical resistivity tests. Carrying out 6 numbers field thermal resistivity tests. Carrying out physical and mechanical, thermal and chemical laboratory testing as follows, which is very important size. It's giving physical, mechanical, thermal and chemical laboratory testing. It's very important. Its range of tests, you can say soil samples, range of tests. This is, which is particle size analysis. Particle size analysis, materials passing number 200 CU, moisture content, Atterberg limits, which you know, liquid limit, plastic index, all that. Modified Proctor density, you know, California bearing ratio CBR, that is used for roads. Lab thermal resistivity, permeability, chemical analysis including determination of chloride content, sulfate content, pH, calcium carbonate, and magnesium. Oil and grease and petrochemical hydrocarbons. These are tests related to, you can say, laboratory, and you may call them generally full range, though it's not complete full range. Yes, these are very important tests because particle size is very important. It depends on, we have to do so much so much testing on that to know what size is or fineness is, all that. moisture content at work limits. All you have studied that is just a kind of information that it has been accumulated one place. Oil and grease and petroleum hydrocarbons, and in groundwater you can say chemical analysis including determination of chloride content, sulfate content, and pH and magnesium oil and grease and petroleum hydrocarbons, performing engineering analysis of field and laboratory findings, developing conclusions and recommendations for design and construction, and reporting. So these 11 points are written here, which you can say constitutes a scope of this report. It's a specific one in this case, but there can be whatever level of scope, whatever size of scope, there's no limit. Because this was a big project, so scope is extensive. And what project says, there are description of sites. Just for your information, I read it for you. There's nothing to do with report. Just the information size. It tells you what is this project. This project planned at whatever site up to in 2000. Existing plant comprises certain identical trains. Total 826 MSCs having gas separation and condensate stabilization, whatever it is. So this is just now new processing facility shall include as follows. We were talking of gas treating, molecular sieve dehydration, NGL recoveries, acid gas compression. Now site is located in remote area, and we can say we are not worried about this, we are worried about report. So weather conditions we can know weather conditions, well, still I read for, maybe you are interested in writing some report about soil investigation if you are related to, or you may see some report, that's a possibility. Prevailing conditions must be shown somewhere, and site is situated in Abu Dhabi where a hot arid climate prevails. A hot arid climate is one where evaporation exceeds precipitation. Evaporation exceeds precipitation, such as rain and dewfall. This climate regime produces characteristics hot desert terrains. Average annual rainfall may only be a few centimeters, even only a few millimeters in some parts, which usually occurs seasonally and sometimes only from a single cloudburst. Summer shade temperature are frequently in excess 40 degrees Celsius, and humidities may be around 100% near coast. Contrast between maximum night and day temperature, maximum night and day temperatures, and between night and day humidities is often great. Strong persistent winds are normal in many areas. This unfavorable climate imposes adverse conditions on concrete structures such as high temperature and high seasonal changes, high humidity and high change in relative humidity, strong dry winds, condensation at night, wind-borne salt-laden dust, high solar radiations. Now, what is general geology of area? Let's have a look at this for our information only, because this affects survey. Now, this state Abu Dhabi lies on coastline of Arabian Gulf, which is mainly of extensive carbonate sediments. Now, this geomorphological model division of mountain and Hiddoments plain of Arabian Peninsula and Gulf area in 4 sediments deposition zones, coastline of this country, that is zone 4, base plain, which is mostly Pleistocene or recent in age, Pleistocene age. Superficial deposits of this zone consist mainly of sand dunes. Superficial deposits, top deposits consist of sand dunes, lows and evaporates together with marine sand and salts. Of course, marine sand and silts. Principal transporting agents of environment is wind and evaporates and rare sheet flow in some valleys. At coastal areas, marine agencies help sorting windblown materials and extensive deposits of bioclastic sand, salty coastal subkhas, salty coastal, which we call in their language subkhas, areas are common and they form large part of this coastline. Although wind-blown materials tend to predominate where a great quantities of dust, silt and sand are moved during periods of high wind. Water plays an important part in controlling this phenomenon. Flash floods are relatively rare, and whatever meandering stream actually reaching coastal plain is usually short-lived after downpour. But standing water table, which may be quite near to ground surface, influences desert processes, as this zone usually represents base level down to which wind erosion takes place. Wind erosion more or less stops when sand and silts are damp. Capillary moisture movement from shallow water table to ground surface readily occurs, enhanced by continual evaporation mechanism. In these conditions, a thick salt crust can build up from continual precipitation of salts dissolved in groundwater, even if they are in very weak dilution. Crystals of these salts are also blown by wind and can contaminate dunes and other parts of desert surface. Capillary moisture movements depends on many factors, but it can be up to 3 meters to 4 meters above water table in fine soils. These deposits are common in desert coastal regions and particularly extensive around this coastline. Coastal salty deposits are known as subkhas as indicated above. Superficial deposits overlie interbedded sandstones, gypsiferous mudstone, siltstone, mudstone, gypsum, limestones, calcisiltites, siltstones and conglomerates. Now, that was just reference of what is about within below ground. Now, what they say, drilling, starting, survey, execution, investigation, execution during period from, you can say in 2002, 28 boreholes were drilled at project site. Boreholes are numbered BH1 through BH26, then BH52 and BH53. These are numbers, not existing ground levels, plant coordinates and drill depths at all boreholes are presented in this table. You can see this table is like borehole number, plant coordinates, that's easting and northing, and existing ground level and drill depth like BH1 to onwards, whatever numbers easting and northing are given. Levels are referred to 131.69 like this, and of course drill depth is given 20 meters, 10 meters, 20 meters, 10 meters, whatever they did, and levels are related to NADD, that's department, so it's just reference. Existing ground levels, plant coordinates, etc., same continues. And then borehole locations were determined by company by activities. So rotary drilling was executed by what I look at. Now borehole logs detailing reference number of borehole, lithological description of materials encountered with depth, structural details of each layer, method of drilling, results of in situ testing, depth and elevation of borehole, and depth of groundwater table are present in logs of boring. We'll see that one. Sampling from borehole. I'm just trying to say what they did in beginning. I'm not going to read all. Just for information, we'll continue our quality engineering. Disturbed split spoon samples. Disturbed split, thus I'm talking of boreholes. Disturbed split spoon samples were obtained from boreholes. Disturbed samples using a split barrel tube sampler were obtained where SPT was performed in soil. Standard penetration test SPD, it is undisturbed rock samples were not possible to be obtained since bedrock level was not reached in any of drilled boreholes. Samples recovered were immediately examined, described, classified, identified, and coded by ACES geotechnical engineer is the name of Arab Center Engineering and geotechnical engineer, placed in waterproof plastic bags and taken to laboratories for testing, storage on same day as soon as drilling of borehole was completed. All samples were protected against weather conditions until they had been transported to laboratory for testing. Care was taken during handling, packing, transporting and storing of samples to protect them against all moisture content alterations. Field testing in boreholes. Standard penetration test, SPT we call it, were performed at different depths in all boreholes to obtain approximate consistencies and relative densities of ground materials. Tests were performed in accordance with BS 1377, Part 9 1990, Amendment 8 to 6495, determination of penetration resistance using split barrel sampler SPT. Test results are shown on logs of boring at depths of tests. Standard penetration test is defined in Legend 2 boring logs attached in appendix. Interpretation of test results are also given there. Then trial pits. During period, whatever it is, 3 trial pits were manually excavated. 3 trial pits were manually excavated. Pits were excavated to a depth of 1.5 meter below existing ground surface, except TP6, which was excavated to 2.5 meters. Locations of trial pits were proposed by company. Locations are shown. Existing ground levels, coordinates and excavation depth for all trial pits are summarized. Now it's trial pits table. Trial pits number, plant coordinates, easting, northing, existing ground level and excavation depth 1.5, 2.5. Sampling from trial pits. Representative bulk samples Representative bulk samples were obtained at every change of strata from each trial pit throughout excavated depths. These samples were placed in waterproof plastic bags, labeled and taken to laboratories for further examination and testing. These following tests were performed on selected samples: natural moisture content, grain size analysis. What is natural moisture content? Is important one. Grain size analysis, percentage fines passing sieve number 200, Atherberg limits, moisture density relationship modified one, moisture density relationship modified one, California bearing ratio CBR, thermal resistivity and chemical tests. All laboratory test results are presented. Trial pit logs including plasticity index, in situ density, modified Proctor and CBR tests results are presented. Field testing in trial pits. All sides and bottom of each pit were thoroughly examined and described by geotechnical engineer according to ASTM 2488. Soil classification was adjusted according to ASTM 2487 after completion of laboratory testing. In situ density test was performed in each trial pit every 0.5 meters, half a meter interval as shown in trial pits logs. Field density test. 14 numbers in situ density tests were carried out within site area every half meter depth in trial pits and at 1 meter depth in area of BH5, BH7 and BH22. Test results are summarized. Test was carried out in accordance with ASTM 155600 density and unit weight of soil in place by sand cone method. Soil electrical resistivity testing. Eight 18 sets of electrical resistivity testing were conducted at site at selected boreholes and trial pits locations. Each set of readings consists of 5 observations you can say. Each set of observation consists of 5 readings at different spacings between electrodes. These are number 1 0.75 meter, number 2 1.5 meter, number 3 is 2.355 meters, 2.25, number 3 is 3 meters, number 4 is 3 meters and then 4.5 meters. Interval spacing in 2 directions perpendicular to each other. Test was carried out according to STMG 5795A standard method for field measurement of soil resistivity using Werner 4 electrode method. Portable Megger DT5/4D digital earth tester was used. That is portable Megger. Test results are presented. Okay, now field soil thermal resistivity test. 6 number thermal resistivity tests using field thermal needle is important one, were carried out at locations of these boreholes at 1 meter depth. Field needle was penetrated into soil and measurement of resistance of thermistor. Measurement of resistance of thermistor in probe was recorded using DMM, that is digital multimeter, attached to thermistor point in front panel of power supply unit. Soil thermal resistivity was determined depending on temperature difference in time interval. Temperature of probe during test was calculated using temperature resistance relation, taking into consideration field needle characteristics constraints. Test was carried out according to IEE Standard 442/1981, Institution of Electrical Engineers Guide for Soil Thermal Resistivity Measurements. Now, Laboratory testing is very important on samples collected. In order to determine physical, mechanical, thermal and chemical properties, which is physical, mechanical, thermal and chemical properties of ground materials, laboratory tests were performed on selected samples from boreholes, trial pits and from existing surface. Laboratory test results are presented, which we did. Laboratory tests were moisture content, ASTMD 221698, laboratory determination of water moisture content of soil and rock, grain size analysis according to ASTMD 422 6398, particle size analysis of soil, minus number 200 C1 according to ASTMD 1140, amount of materials in soil finer than number 200 at 75 micrometer C. Ether-bug limits of soil according to ASTMD 4318, liquid limits, plastic limit and plastic index. These are three: liquid limit, plastic limit and plastic index of soils. Modified Proctor according to ASTMD 1557, laboratory compaction characteristics of soil using modified effort 2700 kilonewton meter per meter cube for moisture density relation. Yes, then modified Proctor is according to this. Character of soil using modified effort. California Bank is a CBR according to ASTMD 1883-99, CBR California bearing ratio, laboratory compacted soil. Laboratory permeability according to ASTMD 2434-94, permeability of granular soils constant head. Soil thermal resistivity according to IEE standard 442-1981, IEEE guide for soil thermal resistivity measurements. Water soluble sulfate content of soil according to BS 1377 parts 1990, amendment 902896, determination of sulfate content of soil, clauses 5355. Water soluble chloride content of soil according to BS 1377 Part 3, 1990, Amendment 902896, determination of chloride content, Clause 7.2. Calcium carbonate content of soil according to BS 1377, Part 3, 1990, Amendment 2896, determination of carbonate content, Clause 6.3. Magnesium of soil according to ASTMD 511, 1998, calcium and magnesium of soil. Oil and grease and petroleum hydrocarbons in soil according to Alpha 20th edition. pH value according to BS 1377 Part 3, 1990, amendment as above, test 9, determination of pH value. Classification of soils for engineering purposes according to ASTM 24798, classification of soils for engineering purposes. Description of soils according to ASTM 248893, descriptions, identification of soils, visual manual procedure. Codes BS 5930 1999, codes of practice for site investigation. In-house computer facilities were used for calculations and analysis of test results. All laboratory test results are presented in Appendix D. Now, surface and subsurface conditions. These are observations you can say from this. Observations from these tests. Boreholes show that there are general similarities and continuities of subsurface materials encountered. However, some local variations were observed within whole site area. Generalized subsurface profiles AA and BB are presented in figure number 1, 2. We'll see. Section B for Appendix B. Location of lines are shown on different figure. 1. Appendix A. Profiles were constructed by direct interpolation between materials encountered in boreholes. Lines connecting various ground strata are made for illustration purposes only and not to be considered as actual field conditions. Detailed information about materials encountered can be obtained from logs of boring in Appendix B. Materials, physical and mechanical, of course thermal, sieve analysis and Atterberg limits test results were used to classify soils according to STM D2487 Unified Soil Classification System. Various tables given legend of boring logs in Appendix B were used to describe relative density of coarse-grained soils and consistency of fine-grained materials. Natural moisture content, modified Proctor, CBR permeability and thermal resistivity were also carried out on selected samples from site. Further information about materials encountered and their physical and mechanical properties can be obtained from Appendix. Materials chemical properties, sulfate content. Sulfate content expressed as SO4 for soil and samples tested from boreholes and trial pits are shown in this table D81. Chloride content for same soil samples are also shown in table this. Other chemical contents in soil like calcium carbonate content and magnesium were determined and tests are given. Oil and grease and hydrocarbons in soil for same samples were determined. Test results are summarized and given. pH value. Measured pH values for test soil samples are above 7. That's measured pH values for tested soils samples are above 7, which indicate that soils samples are slightly alkaline. Therefore, no acid attack on concrete is coming from soil is possible. Concrete may be free from acid attacks. BRE Special Digest 1 2001 requires no changes in requirements of cement content and maximum water cement ratio for type of cement as long as pH values remains above 5.5. So there is no problem in, you can say, requirement of cement content and maximum water cement ratio for type of cement as long as pH value remains above 5.5. Groundwater and cavities. Free groundwater was encountered in boreholes down to maximum explored depth 20 meters. Free groundwater was not encountered. So this is water-free substrata. No cavities were encountered in any of boreholes down to maximum drill depths. General discussion for choice of suitable foundation. This is also very important from engineering viewpoint. We have to understand this is because this is practical recommendation by soil engineers. Now, in designing foundations, engineer must satisfy two independent stability requirements which must be met simultaneously. There should be an adequate safety against shear failure within soil mass. Working load should not exceed allowable bearing capacity of soil being built upon. So this is safety against shear failure. Probable maximum and differential settlements. Probable maximum and differential settlements of soil under whatever part of foundations must be limited to safe and tolerable limits. Footings on sand So this was about there are 2 points. One is for shear and other differential element. There should be an adequate safety against shear failure, and also probable in shear failure, working loads should not exceed allowable bearing capacity of soil, and probable maximum and differential settlements of soil under whatever part of foundations must be limited to safe and tolerable limits. Now on sand, site is underlain by sand, so choice of foundation depends primarily on relative density of sand and position of water table. Relative density determined bearing capacity. Relative density determined bearing capacity and settlement, whereas position of water table has an appreciable influence on bearing capacity and settlement. Consideration now what we do for settlement. Unlike cohesive soils, cohesive means clay soil. Unlike cohesive soils, settlement in cohesionless soil takes place during initial application of foundation loads. I'm talking of non-cohesive soils. Unlike cohesive soils, settlement of cohesionless soil takes place or affects during initial application of foundation loads or actions. Is time independent and is in most cases governing factor in selecting design soil pressure. A 1 inch or 25 mm maximum limit of settlement in buildings is generally adopted on premise that if maximum settlement is restricted to this amount, 25 mm, differential settlements among footings of a given building would be within tolerable limits. A relationship was developed in 1948 by Tarjagi and Peck between soil pressure to produce a given settlement 25 mm and value from standard penetration test SPT on basis of general knowledge of loads, settlement and N values of various sand supporting footings. Bearing capacity. No completely adequate vigorous theory exists for calculating ultimate capacity of footings. However, satisfactory approximate solutions have been obtained on basis of vigorous simplifying assumptions. Tarjagi 1948 and Meath of 1955 demonstrated that bearing capacity of footings is derived from two sources: frictional resistance due to weight of sand, frictional resistance due to weight of sand below level of footing, and a frictional resistance due to weight of surrounding surcharge of backfill. Unit weight of sand is in itself not an important variable in determining bearing capacity of a footing. However, if sand is located below free water surface, only its submerged weight is effective in producing friction, and therefore position of water table is with outstanding practical importance in establishing bearing capacity of footing on sand. And bearing capacity is also greatly influenced by relative density. Bearing solutions derived show that ultimate bearing capacity of footings on sand depends mainly on four variables. That is, bearing solutions derived show that Ultimate bearing capacity of footings on sand depends mainly on four variables: position of water table, relative density of sand, width of footing, and depth of surcharge surrounding footing. Relationship between and value from that standard penetration test and bearing capacity was established. However, this relationship is approximate. Now, what type of foundation we have to do is a question mark here. Choice of particular type of foundation depends upon character of soil, presence of groundwater at site, magnitude of imposed loads, and project characteristics. One has to choose type of foundation which is not merely safe but also economical. For particular case, no information about imposed load is available, so leave it. Water table was not encountered, leave it. Materials encountered during site investigation are medium dense is important. Materials encountered during site investigation are medium dense to very dense sand, and these are shown in borehole logs. According to this condition, shallow foundations are considered satisfactory to be used per following the recommendations. What are these recommendations? According to field and laboratory investigations, subsurface conditions, engineering analysis, and practical experience, it can be concluded that proposed structures, facilities can be satisfactorily supported by ground at site, provided that following recommendations are taken into our considerations. Foundation depth and type. Shallow foundation, you can say isolated footings connected with tie beams and or stiff footings or rough foundations can be laid at different depths. Materials encountered at those depths are medium dense to very dense sand with silt materials, either sand or sand with silt materials, which is considered suitable to provide adequate support for proposed structures, facilities. No groundwater table was encountered. So no dewatering would be required. Below foundation level, whatever soft, organic, or whatever other unsuitable material exposed shall be removed and replaced with well compacted granular material. So there is a direct indication in certain cases for soil improvement. Exposed subgrade at foundation level is top 20 cm shall be moisture conditioned and compacted by appropriate means to 95% maximum dry density as obtained by modified Proctor ASTMD 51557. A suitable cover should be provided about top of foundation to protect foundation ground from erosion and foundations from thermal and weather seasonal variations. Now, in areas of borehole 15, 18 and 21, excavate existing ground surface to 2 meters depth to reach natural soil. Prepare exposed subgrade as in the item above. Construct engineered fill. This is important. Construct engineered fill in layers of compacted, selected, graded, granular backfill materials 25 cm thick each. Backfill should be extended laterally minimum of 0.5 meter from edges of foundations. Backfill should be compacted to 95% of maximum dry density as obtained by modified Proctor. Engineer fill shall reach foundation depth shown. So 95 it is, 98% can be. Now, plate bearing test shall be carried out every 1 meter of engineered fill. Plate bearing test shall be carried out every 1 meter of engineered fill and at foundation level to verify allowable bearing pressure and total settlement. Tank foundations and hydrostatic testing. In general talk, tank can be supported by either reinforced concrete raft foundation or by reinforced concrete ring beam. Foundation depth may vary on natural subgrades, or tank can be placed on selected and engineered fill materials at 0.5 meter higher than surrounding ground level. Final foundation depth shall be decided by designer according to operational requirements. In order to enhance stability of tank, in case tank be placed on engineered fill, it's advised that edge of tank pad be extended outside shell by a distance of at least 2 meters. Side slope of pad edge shall not be steeper than 1 vertical to 2 horizontal. 1 vertical is to 2 horizontal. Types of materials to be used for filling purposes for tank pad and site grading and their compaction criteria are addressed in item. Backfill materials and compaction criteria. Net allowable bearing pressure recommended and presented in table number 3. In case tank would be placed on engineered fill, value of 2.5 kg per centimeter square is recommended to be used and shall be verified by plates bearing test. 2.5 kg per centimeter square, 25 tons it says. In case tank would be supported on ring beam, dimensions of ring beam, however, shall be carefully determined so that applied pressure from ring beam is very close to that from materials inside tank. It is recommended that ring beam be embedded for a minimum depth of 0.5 meter below surrounding grade, which would place ring beam foundation minimum of 1 meter below bottom. Surface of exterior parts of tank pad outside tank shall be protected from erosion due to rainfall, runoff, wind or flow of spilled oil. Surface cover of bitumen, cement, bitumen sand or gauge. Locally available silty sand material may be considered for this purpose. This is surface of exterior parts of tank pad outside tank shall be protected from erosion due to rainfall, runoff, wind or flow of specific oil. Surface cover of bitumen, cement, bitumen, sand or gauge may be considered for this purpose. It's recommended that tanks be hydraulically tested before commissioning to check structure and to prove foundation. This may be done by filling that tank in 4 equal increments. Water load of each increment should be maintained until settlement ceases, which is expected to occur rapidly. It is recommended to carry out this test in accordance with BS 2654 or equivalent international standard. Allowable bearing pressure for shallow foundation. Allowable bearing pressure was determined for foundation ground as specified above using practical experience and results obtained from field standard penetration tests and empirical equations developed by Tarjagi and Pack. Made of and modified by Bowles, taking into consideration a safety factor of 3 against shear failure of soil. Accordingly, net allowable bearing pressures values recommended to be used for design of footings with different widths and at different depths based on 25 mm settlement. Foundation settlement. Foundation settlement was checked using recommended allowable bearing pressure values and obtained and values from standard penetration tests and found to be less than tolerable limits of 25 mm for isolated stiff footings and less than 50 mm for raft footings. Raft foundations. Most of settlement will take place during construction period. Soil design parameters. Soil dynamic parameters like dynamic modulus of elasticity. Soil dynamic parameters like dynamic modulus of elasticity and dynamic shear modulus are estimated from empirical equations and practical experience using laboratory and field test results. For design purposes, Poisson's ratio mu of 0.33 is recommended to be used for cohesionless soils. SV and smoothing. Okay. Representative values of shear wave and compression velocities are presented now. So this is, we will take details later. My purpose was just to apprise everybody about how quality is maintained everywhere, and we have to think of, as I said about soil report, I tried to refer to you about this subject. It's really very important to understand this. Soil report. I said soil report requires a thorough review through engineering section to be made sure that recommendations included by soil or geotech engineer have been covered within design report. In case of whatever pinpointed observation, it should be brought to notice of designer through agreed procedures. Now, testing of all materials. According to specification, requirements must be conducted to ensure demanded quality adhering materials. Particularly, reinforcing bars is an important item for purpose of procurement rightly. What I am saying is, Steel bars that we purchase, particularly here in our crowded areas, I've seen there is no quality maintained on these steel bars. Unfortunately, it is. I don't know how it happens, but it is happening. It has been happening for years and decades, and nobody listens to. First is these bars are banned for transportation into trucks. It's important. How it is done, I don't know. Who decided for this, I don't know. This happens. We least bother about transportation because we don't want to spend money for trailer, or maybe trailer cannot reach that site. There are other alternatives as well, but we don't worry about that. We are we have decided, all people decide that let it be bent and brought to transported to site using truck. Really, it's unbecoming. This is not acceptable, but it is happening. It happens. What can I do? You can say there is no need of test because you have already broken everything. Your bent steel, and then you straighten it. First you have bent that. You will put that on site, maybe on soil. There may be moisture, there may be water, and you will of course invite. First of all, you brought bent steel, and now you will spoil it by exposing it to moisture. What a beautiful state of construction. A country which has millions of engineers and hardly, maybe few engineers bother about this, but generally they don't mind it. If steel is rusted, no problem, they use it. Beautiful, they use it. That's what we say. Quality consideration is very important at this stage because there is no quality actually. There exists no quality. When we are talking of testing all materials according to specification requirements which must be met, we can also hold concrete trial mix if required, or we can use or refer to old or recently conducted tests. Now, it's not necessarily define everyone all time. Site engineer must ensure that precautions are required to be taken on site. All precautions are required. That must have been explained to all responsible skilled craftsmen as well as leader, crew leader, foreman or supervisor, and charge hands. These requirements, what we have to do, should be included on referred method statements, relevant method statements. Clearly, all detailed method statements should be approved ahead of carrying out whatever activity. I think you can read this minutely as I'm going for 5-10 minutes. It's important for me just for little walk due to my problem in my leg, my feet. I have to stretch it a little in 5-10 minutes and come back. Please don't mind. Okay, so back again. Let me back now. I'm back. We'll continue. I was talking something, and you can say now, as we did. Let's say all quality control must be conducted during concrete pour. Now, what I'm saying is here, as we said, whatever quality control is required, quality activities are required. Says site engineer through engineering must make sure that whatever drawings contain, whatever details are therein, or ductile detailing of reinforcement, whatever details are missing should be read, should be understood, pointed out. And if you think that you have some reservation, it must be discussed. Significant for proposed materials to resist forces, which include materials should come to standards without any adjustments, without doing any adjustments. No compromise. Generally, it is RCC that is often included on various buildings and certainly considered for designs. Significant to produce concrete works with good quality, and no batch of concrete should be allowed to be poured unsupervised. Site engineer must ensure that whatever precautions are required to be taken on site should have been explained to all responsible skilled workers, craftspeople, as well as foremen or front leaders. All requirements should be included on relevant method statements clearly in each and every term. All detailed method statements should be approved ahead of every activity. All quality controls must be conducted during concrete pour. These may include site tests such as slump, air voids, temperature, and concrete mixing to concrete finishing time, which I can say when this mixing is started and when the finishing of that concrete, whatever number of hours are admissible, those must be maintained. Bar bending schedule, very important item, which must be worked out correctly according to formula given per code. That may be whatever code you are following in BS 4466 or BS 8866 or whatever your own, which should meet requirements. And we have to apply all practical requirements to that BBS. You know details. I'm not here to tell you details. You know everything. We have to remember that reinforcing bars during earthquake action time change their behavior. Members change their behavior. Means when members change behavior, bars of course change behavior. When we say columns and beams both interchange because of, generally we talk of vertical loads, gravity loads, but when we talk of seismic actions, part of that load converts to horizontal seismic shear we call it, and that applies horizontally. Certainly it has to change behavior of these members temporarily. Of course, percentage behavior, I'm not saying total behavior. So binding of bars, tight binding of bars, displacement of bars are question marks here. No bar should remove position. And vibrators should not be allowed, as you know, to touch whatever. It should be allowed to touch any rebar any time or shutting any time. Formwork in time. Overvibration is prohibited. No over vibration should be allowed, which is not accepted. No pulling or pushing of concrete is accepted. Segregation is not accepted, and you know what segregation is. When fine aggregate and coarse aggregates are separated from mix, that's called segregation, which is not acceptable, and it can happen due to more than required drop of concrete or over vibration. All concrete must be vibrated, and in case of void formation, thorough investigation should be conducted and then remedial actions proposed. Concrete spaces are very important. Concrete covers, we call them, must be site fabricated if possible. That's best when keeping in view family of concrete. You can use plastic spaces also, MDP or SDDP, and at no use of using LDP, because this will no use. And if you use HDP or MDP, it's fine. Cover is too serious a matter, but to be considered. Precast covers, well cured, can be used. Plastic covers, if strong enough to resist force of steel and working, if it can bear loads of foundation rebars, can also be used. Formwork should be erected based on correct and safe designs of preparatory works. Safety is of utmost importance. Safety first criteria should be fully considered and implemented. Safety in formwork is very important issue, and there are two types of problems in foundations. One problem exists for suspended slabs formwork that can open during casting, which is a big problem, which can cause accidents, accidents of loss of material and loss of lives, fatal injuries, and also when you cause columns or other vertical structures, due to concrete pressure, sides are prone to open. Due to horizontal pressure, when it filled up, even concrete pressure sometimes can open sides if it strikes right to shutters, form surfaces. We have to be very considerate about that, to take into consideration all these points. Accidents can be caused by opening of sides, and that's very dangerous, particularly in case of slabs and also in case of walls at height. So quality control tests such as slump, cube, compressive strength, additional tests should be considered for core tilt. Tilts can also be taken. Of course, curing is very important. Curing is responsible for life of concrete, durability of concrete, and therefore must be given due care, controlled under direct command of responsible, experienced staff. No leniency or worry about cost of water, curing, compound or Hessian or polythene sheet has to be accommodated. Method statements must be written. General method statements for curing for every member, for foundation, for step columns, for grade slab, for framing members individually as well as combination. This is very important, in which you have to use curing compound, we have to use gunny bags or Hessian bags, we have to use plastic sheet, we have to use sometimes sand or even polystyrene. It's part of thermal curing. We have to use plastic sheets to cover immediately. This we will discuss in method statements, already discussed, so we will discuss the problem. Generally, it's a big issue. People do not understand curing, what curing is, why it is done, how it is done. And of course, where atmosphere is hot, dry, arid, as I said, precipitation is less than evaporation. So we have to concentrate on curing, because if there is non-compliance in curing, you can't solve it, you can't revise it, you can't reach a conclusion that curing issue is over. It's continuous, it's regular, but even then, I don't know what happens. If you miss curing due to whatever reason, it happens in rare cases. In rare cases, it happens when, particularly when people are tired, they are happy that they have done a lot of job slab. They want to sleep, and then that excitation, in that anxiety, they are over enthusiast and least bother what happens after slab. So this is not acceptable. There must be a curing specialist gang or crew that will take care of, if otherwise it's a problem. But there's no solution to that. If curing is not done, there's no solution how to do it. Now, we have to be very serious about curing issue, because you have to take very difficult action in case of failure of concrete. It happens in many cases where people are honest, not cheats, and I have experience also. So we have to be very serious about curing, much more serious than we were serious about pouring. Pouring and curing. We are serious in pouring because we wanted results. We want to say, we have to tell whole world we have done this. But curing is not seen, it's not measured, it can't be witnessed, but it has to be done. If it is done, this means your pour was successful. And if it's missed somewhere by whatever way, by whatever ignorance, your pour was useless, you can say. It was no use. It's like no concrete. Defects are observed on striking forms. When you strike column forms or beam forms or wall forms or slab forms, whatever formwork you remove, you strike out, there could be whatever sort of defects. It says duty because it's my product, I'm selling you this product, it's my responsibility to make sure as a contractor that I have done curing as well as I have done rectification of defects. For doing rectification of defects, we should know what defects are. Once we open shutters, it's duty of our people to make sure that concrete was all set well, and if you find defects, immediate defects or defects is coming once, we have to be very considerate on that. If there is a defect seen after shutter is open, don't shame, don't worry. Defect it is. It can happen, there are chances, because there are so many hands working, so many hands transfer activities, and there are hundreds of batches sent through, and there are chances that people become lazy, they're tired, they don't know what will be consequences. Consequences available, people are available. Even then, defects are invisible. We have to think of those defects to correct before. We have to understand these points. There are no remedial measures for defects, and those must be taken approval of in general. There is no requirement for every defect to be given method statement, position method statement, documentation. No need. If you already have generalized NCRs or methods, generalized methods for every repair. We can save a lot and we can repeat same method for every concrete defect. All time we can do that. I have already discussed the soil improvement, which is a must. Soil improvement to get required safe bearing capacity. Weak soil is removed. Weak soil is replaced by engineered fill or whatever method. Imported desert fill or grid fill can be used for purpose of limiting liquid limit as well as plasticity index. Backfill is one activity that makes a lot of difference. On future of foundations, it must be rightly conducted. It has been observed that site engineers try to neglect this important supervision, neglects the supervision and save project time by filling thicker layers. It's not a good practice, it's not acceptable. Backfills should be in good compliance to agreed specifications to achieve 95 to 98% field density. 95 to 98% field density. General fill can be compacted to 90% field density. Construction sequence should be correctly followed during scheduling. Foundations should be planned as far as possible to be cast monolithic. This general guidance. Columns should be cast first. Beams and slabs should be cast in one-time monolithic. All connections should be done to meet requirement. It is to be ensured the proper bands are used in brick or stone buildings that have been required for horizontal resistance. Long walls should be inserted with bonding columns and bonding beams per specification. Infill walls should be taken up for later after completing framework. Connections between columns and walls should be made with proper fastenings. All constructions activities must be complied with designs as well as specifications requirement. No negligence should be allowed. Quality engineers have to similarly involve to check and inspect all activities by observations in addition to signing ITPs. So I say no negligence will out on construction activities. Resident engineer should keep an eagle eye on activities. Supervising engineer, to say rather than resident, supervising engineer should keep an eagle eye on activities. And quality products should be must. It's a must. You can't say otherwise. Whatever services too can break due to horizontal forces, which require strong and durable fills with durable. Now, it says during earthquake action, every service system can break into horizontal forces which require strong and durable fills around with durable joints. All elements of buildings as well as finishing should be well secured and become durable so that during earthquake impact these are not dissociated or torn out. Points for attention. Points for attention on site. Site engineer should not decide self about engineering each decision or mistakes for whatever reason whatsoever. Aberrations from quality compliance and their suggested solutions are noted as follows. Important point are noted as follows. Rusted and bent rebars are delivered to site or to fabrication yard. Straight lengths without rust only should be used. Rebars are placed, steel and rebars steel that is placed, that is delivered to site or it is rusted on site should not be used. Rust must be removed and attempt should be made to procure straight bars, not bent bars. And if you don't have transportation problem, if you have transportation problem, shorter lengths can be procured rather than full lengths. Rebars are placed on ground soil. Means it happens, I have seen myself. Rebars are placed on ground soil and not on raised platform which may be wooden supported or other supports. Without covering with polythene sheet, these are placed, these are left. Precautions should be resorted to for good handling and storing. Fabricated rebars are not properly sorted, that is fabricated rebars. Tagged, not tagged properly and stored in a shed or under protection from moisture content. Right tracking should be maintained by designations of relevant elements. Rebar is very big issue, you see, because this is what you have to do. Without rebars, concrete is useless, and with rebars rusted or abused, concrete is partly useless, and rebars too are partly useless. Why you make it useless, I don't understand. Reason behind that. What's the reason behind that? Nobody can understand that. I don't have any sense to understand such. Believe me, I can't understand this foolishness. We say rebars are placed on ground soil and not on good wooden or other supports. Without covering, these are left. Without polythene sheets, these are left. Precautions should be resorted to for good handling and storage. Even fabricated rebars are not properly sorted out, tagged and stored in a shed or under protection from moisture contact. Right tracking should be maintained by designations of relevant elements. Rebar dowels must be maybe forgotten to place it in a various joint connection. Chemical anchors should be used for forgotten dowels. Do not chip concrete to insert small hook. Drills shall be required to chemical anchors recommendations. Insert embedments of services at various locations may be missed. Approved shop drawings should be used for checking inserts, locations, coordinate inserts, locations to structural details. Blockouts for various services may be missed. Approved shop drawing should be used to overcome such problems. Coordinate these locations to structural details. Alright. So I say insert embedments of services at various locations may be missed. Approved shop drawings should be used for checking insert locations. Coordinate inserts locations to structural details. Now blockouts for various services may be forgotten, may be missed. Approved shop drawings should be used to overcome such problems. Don't do without that. Coordinate these. Now we say blockouts, then sometimes due to site negligence, certain concrete elements may be missed. By condoning structural drawings, structural drawings should be deeply coordinated with architectural drawings. Generally, facets dowels are forgotten. Well, dowels are forgotten and many lintels are also overlooked. So we have to coordinate all architectural drawings with structural drawings to make sure that structure cannot be forgotten if architecture is forgotten. This may be very unbecoming issue, but it is a fact of life that it happens. It happens, it's a fact of life, and we have to be very considerate about that. Everything is not that easy as we think. Now, opening or bulging of forms at one third of height. It's a very important issue. Opening or bulging of forms. Opening of or bulging of forms at one third of height from pouring base is a common occurrence. Location requires strong resultant supports. It should be taken care of while considering concreting plan. Chipping should be avoided if feasible by providing strong supports. Honeycombing on surface. Honeycombing on surface is a common occurrence, common problem. Vibration should be applied rightly according to requirement, and only experienced or trained person should be allowed to operate vibrator on site. Produce a smooth and nice surface, that's by honeycombing remedial. Do good, specific problem of solution. No? Now, honeycombing on surface is a common occurrence. We know vibration should be applied rightly, produce a smooth and a nice surface. Honeycombing on surface is a common occurrence. Vibration should be applied rightly and produce a smooth and a nice surface. Concrete temperatures are not ensured in range of 5 to 32 degrees Celsius. Concrete is done in temperature above 35 to 42 degrees Celsius. During higher temperatures, such ice requires to be added if mercury is above 32 degrees Celsius. Thick elements or massive block avoid, if we don't worry about concrete temperature, we do a mistake, we cause a mistake. People are not clear about this in our country. They must be trained to understand temperature value. During high temperatures, as such, ice requires to be added if mercury is about 32 degrees Celsius. Thick elements or massive blocks should be poured within 24 degrees, so that heat loss is allowed with If your concrete temperature is not controllable, don't do concrete. Because various concretes, various classes of concretes and various temperatures are applicable. is you have to understand. There may be ordinary member of concrete, ordinary one, just like normal beams, columns, normal slab thickness. In that concrete temperature has to be maintained, and you can later Google or find. If you think you can't control temperature, I would say either learn that properly from literature or from methods. You have to write method statement or you follow method statement. If you can write yourself, think, or somebody else should write for you and for your emails. I'm talking about thick members. I'm talking about thick members, which is very important point. Normal members, which we say columns 30 by 30, 30 by 40, or 300 by 300, all they are little normal members. These are thin members actually. I'm talking about ordinary beams and slabs are all thin members. What I'm talking is about thick members in massive blocks. Minimum dimension of thick members should be 800 mm and it should be 8 cubic meter range, and there is about same having thickness of more than minimum thickness more than 800 mm or 800. That's difference of thin member and thick member, because thickness is more, size is more. Thick member of massive block shall heat up exclusively, extensively, changing gas. If we use thin members, temperature 32 works. If we do thick members or massive block, you have to maintain maximum 24 degrees. We'll see it, how to do that. Void formation in concrete is a common problem. There is no way out. You have to chip out that portion to stronger base, hard base of concrete, and then apply whatever remedial measures we accept. Some people are confused with voids and honeycombing. Be clear, honeycombing has no relation to void. Void is a working error. It is left because of whatever reason. You can't compare it to honeycombing. Void is a defect if concrete stays. So it's a dead material, cannot be you can say applied, we can't be subject to that. Then we can say expositions of rebars is a common occurrence also. Mortar is pasted on those areas to hide exposed rebars. This is wrong. Concrete spacers should be placed all over to meet specified requirements. There is no way that rebar is seen, no way. It can't be accepted. I don't understand some people, they don't understand this much also. That rebar should be behind cover. Rebar should be behind cover. This point must be very clearly understood. We can't run away from this fact. We can't. Congestion of steel reinforcement is generally seen, not anticipated by site engineer. It should be discussed with design engineer, and if it's workable, acceptable, a battle arrangement should be approved. You know, on massive blocks, it's not ordinary curing we talk of. We have to avoid congestion of steel reinforcement bars. Congestion has to be avoided. Rebars are often displaced by electrical conduits fixers during conduits fixing. Steel fixers should replace affected rebars parallel to conduits installation. For higher size rebars, do work perfectly. Mechanical connectors should be used, generally rebar diameter 20 or above. Please avoid avoid overlap. Mechanical connectors were used even in 80s. I used them in 1985, 86 mechanical connectors. So don't run away. Then rebars are often displaced by electrical conduit fixers. During conduits fixing, steel fixers should replace affected rebars parallel to conduits installation. Hardened concrete is, as a bad practice, cut for passing some small air conditioning duct already missed. No concrete should be cut without proper an investigation conducted by either design engineer or resident engineer. No way, you have to coordinate properly before constructing concrete member. Coordination is very important, and if you miss coordination, you will find all types of such defects which are not acceptable. Excessive slump is not reported truly. No information should be concealed, but slump should be tried to be brought down by keeping truck mixing rotated for a couple of minutes. And in case it does not work, mix should not be accepted. During concreting, pour, due to delay, additional water is secretly added. People do it. It's not permissible, but they do it. No additional cube sample is taken for that added water patch, which is not acceptable. If it is allowed, you have to take cubes specifically for that portion. Make sure that the strength is not affected. Though it's not allowed, it should not be allowed. It's a crime-like situation. It is concrete. It's not, I can say, football match. It's not cricket match. it's life match. You are doing something for whole life for someone. Maybe it's not for you, but for that one who's going to stay in that, it's a question of life. We have to respect that way. And that's why I say it is civil engineering that applies to whole life. It's not understood by everyone, but civil expects and respects. Civil must be given that value in society, because civil cannot be measured in terms of money only, fees only. It's like serving God. That's all I can say. Construction joint stop end is not readily available. That is an error, you can say. That is a mistake, I can say. Construction joint stop end is not readily available. We have to consider emergency situation during concrete. Experienced person knows that. Overconfidence should be avoided in construction. Construction is very delicate always, and concrete makes it more delicate. If you can prepare immediately, that's fine. Otherwise, it should be ready-made, or you should have capacity to fabricate it immediately and install. Sometimes block of concrete we are doing, but pouring is big, for which immediate fabrication is not possible. For ordinary slabs of thickness 150 mm, 200 mm, 250 mm, 300 mm, 400 mm, 450 mm, that's not a big issue. It can be done immediately if we have. But for major pours of massive blocks, we have to do something in advance. Otherwise, it shall be a big problem to form a construction joint, emergency construction joint, due to whatever reason, failure of mixing plant or failure of whatever reason, you can say, no reason can be banned. It's very important that stop ends must be readily available, or it can be fabricated immediately when you have carpenters with you. It's fixed as an emergency exercise provision when concrete stops due to whatever defined, known or unknown reasons. Don't be careless about that. Always being careful pays in construction. Construction has many reasons. It has many reasons that you should be alert, because it's question of direct cost, material wastage. We have to avoid material wastage. We have to avoid time wastage, and simultaneously we are bound to achieve quality of work and to handle emergency situation. Otherwise, you can't name yourself engineer. I can simply say that. And not only construction joint is formed, also we should know when everything is reinstated, when next concrete can be done on that, and what's procedure of that in specifications as well as in practice. You can't start new concrete immediately. Even after you are reinstated, you have to refer to your documents, to general specifications, practice of such construction joint reinstatement, and you have to properly do it again by scabbling, and there must be a time gap between this construction joint preparation and new concrete, and surface must be cleaned completely, and accordingly you have to follow it per your agreed method statements, because nothing can be done on your own. It has to be complied with procedures, and structural engineer must be consulted with that, because it's a question of structural durability in future. After all, it's a construction joint, and it is suppose a water retaining structure, and it's also most important. It may affect something else, leakage off. So not only construction joint, it should be proper joint. If it happens in retaining structures, water retaining structures, it's a big problem, because you have to make construction joint with water bar, and that means is another issue. So we have to take into considerations, though it doesn't happen, because in retaining structures we don't do all concrete together. Construction joints, vertical joints, horizontal are there. There are some safety. Construction joints not correctly fixed Location should either be indicated on drawing or be agreed with engineer prior to commencement of pour. Both should sit and decide about that. Construction joints not correctly either hacked or scabbled before doing next concrete. Do not run fast. Construction engineering is not fast in every activity. Scabble or chip out joint surface to expose aggregates and to remove all latents, and then proceed for cleaning and laying new concrete according to agreed procedure. And also think of, you have to keep ready stand by vibrator. It's not available, it's your fault, you have to keep it. It's very important to have additional vibrator, standby vibrator, to meet working requirement when busy vibrator or working vibrator fails. Vibrator should be checked for working before commencement of pours. And person who uses this, operates this, must be well trained before one operates on this in concrete. And not only its use but also its maintenance, after use how it should be cleaned, and before use how it should be tested. And then also question of curing. Curing is not started in defined time. Curing is not continued per requirements. Hot weather requires immediate curing, particularly on exposed or unformed surfaces, which can be done by spraying curing compound if you must have. Spraying curing compound even. Polythene sheet can also be laid, can also be spread on concrete surface immediately for immediate protection. Curing should be effectively carried out to defined duration by personal attention of site engineer or manager, whoever is in charge. Curing is not completed for required period. Do not ignore curing. Curing ignorance can cause a major problem. A non-conformance report on this account may have no solution. Foreclosing non-conformance report. It's very easy to pour concrete, but it's extremely expensive to dismantle and rebuild. Solution of missing curing is only to rebuild, and you know how expensive it is. It costs you money, it costs you time, it costs you quality, and it costs you everything. You have to pay for nothing because you have to work twice, and you shall be compensated from nowhere. It's your own money you fired in, it's your reputation you fired in. Your reputation is jeopardized. Be careful. Time doesn't come back, money doesn't come back, reputation doesn't come back. Black mark is black mark. Incorrect cut rebars are forced to be placed in. Incorrect cut rebars are forced to be placed in and unusually banked. Prepare good bar bending schedule, as I said before, prior to starting cutting and bending or fabrication of bars. Excel sheet is good for this. You can yourself formulate, you can formalize. No need of any software for that. You can use your formula for whatever shape. Hardly there are 20-30 shapes, not more than that, practically speaking. So every engineer knows software of Excel, and you can formalize cutting length yourself. And easy, once you have cutting length, you can find members and everything, and you can go on with that. Stirrups which take shear are not rightly centered. Do proper fixing and centering. Reinforcing bars are not centered properly. Do proper fixing work. For those rebars which rest on chairs, there are so many rebars, particularly in upper layers, heavy or light both, who rest on chairs, we call them chairs actually, is not rightly cut and fixed. You have to check before fabrication all required dimensions. Do not depend on steel fixers or overconfident. Rebar fixing is complex activity. Make sure that it is carried out correctly. You must have a conception of how to assemble these bars. Cutting is one part, cutting and bending. Assembly is another part. Both are different, but for same activity. One stage is cutting and bending, another stage is assembly on site. Reinforcing bars not well secured. Bind bars properly without worrying about binding wire cost. Check fixing arrangements over all joints. Tie bolts are not tightened properly. Use correct dimension tie bolts and fix properly as required. Plumb is not inspected to standards. It's difficult exercise to inspect dimensions, locations and verticality, but should be conducted particularly for elements to bear equipment or where facet is involved or fair face is involved. Extra previous concrete is not chipped out. Site should be kept tidy. In every respect, chip all surplus required concrete. Holes are not left for cleaning out dust from forms. Holes are not left for cleaning out dust from forms. It's practically required to dust out preparatory works. Use compressor or clean out preparatory works. We're talking of quality, we'll take remaining later on. Quality systems, quality, individual quality, element quality, designs, all stage designs, construction, all activities, method statements, express detailed format for performance, time unchangeable, cost invariable, escalation, risks must be foreseen, reliability must be achieved, safety and serviceability and durability, other known knowledge area facts in analysis must all probable problems to be understood, synthesis, all solutions network must reach compatibility, thinking, and only way contemplation must be achieved, applications must be affected, which is called engineering. All given various method statements in certain files, for example, blinding concrete. This is about how to receive, how to fabricate, and how to store reinforcement. What about block works above grade level? About plastering and rendering block walls and RCC surfaces. About roofing system, we generally call it inverted system. About laying ceramic tiles, ceramic floor tiles. Building drainage system in general, not very specific. About floor screeds. Concrete produced interlocking blocks, how to lay them, what is the purpose, how. About some roadworks on driveways. Certain preparatory works pertaining reinforcement placement. Pouring concrete. About post-concrete repairs. Sewerage pipeline laying work from manhole located in premises to existing. This is a particular application of some site. And then you can say also some more documents that are required to be shared with you in various capacities. I had shown you before one house design synopsis. This was shown before, but I just represent it. This is my house was constructed. My own house, actually, you can say. It's my own house. First, architectural details, as you can say. There's one part of house, another part behind this. You can see here it's quite 10 meters from here to here, and it is about more than 11 meters from this end to this column. It's more than 11 meters, about 10 meters here and same here this side. This is a small house. Its floor to floor is 3,250. Riser is 125, thread is 250, and I calculated floor height based on risers, and I did not do otherwise, means floor height into find number of risers and size. No, I fixed risers and then fixed floor height. This is total plan of that house. This is here and this is here, as I said. Then in this specialty is that this portion is double floor, double height. This is second floor for study room. This is terrace, above terrace, top terrace, you can say. This is kind of sketch which represents elevations. You can see any elevations, provisions of glazing. You can see this provision of glazings here. No lintel, just ordinary walls, glazing here, so that every portion of this hall is illuminated without electrification. Electrification is required only at night time. You can see approximately percentage of, you can see 1, 2, 3, 4, 12, 16, or 6, 16. Out of 16 squares, 1, 2, 3, 4, 7, 7 or 16 in this case, you can see 4, 4, 4, 16, 1, 2, 3, and so 7, and here it is 4 to 6, and 9. So 7:9 ratio, you can say. These are 7 squares, 7:4, 4 to 6, 6 and 3, 9. 7 covered and 9 open. You can see that? 7, these rectangles are open. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 7 is covered. So you can say 7:9 ratio, 7 covered, wall cover 7, and 9 is ventilation. So it's more than 50%. You can say 8 should be there for, which is 9 is more than 50%. Illumination area, window area. If you see here, 3, 3, 6, 8. These are 8. 1, 2, 3, 4, 5, 6, 7. 7 and 6, 13. 14, 15, 16. Ventilation. And here it is 3, 4, 5, 6, 7, 8. 8 and 4, 12. And 4, 6. So 50% here. See difference. 50% here. And also if you see here, 3, 3, 6, 12, 12 and 4, 16. 16 is light, 4 and 4, 8. 8 and it's 50%. You can see here also 50%. Here a little less, I think. You see 1, 2, 3, 4, 5, 6, 6, 4, 10, 12 and 24. 24 and here it is 4, 3, 7, 7 and 7 here 14. 14 to 16, 20, 26, 26, and this is, I think, same. So it's less than 50. Or what I'm trying to say, I try to keep maximum area for lighting. This is, this is front elevation showing stepped windows to transmit sun rays into covered area. You can see also similar follow-up in right elevation showing stepped window for sun rays. You can see that, as I said. This is left elevation, same one. This is parapet, is the minimum number of bricks. And this is plan of slope stair cover. This is framing now, foundation, and there is then this is basement floor, slab, foundation beam frame plan. This is foundation, basement floors, foundation plan. This is your basement structural framing for ground. And like this, you'll see structures everywhere. You can see structures, columns are shown, same size column. In solid, you can see this black. Second floor structure frame plan. Then you can see this stair. These architectural decorations, etc. This is a location nameplate. Right side windows and driveway, front windows and zoning setback. Building view can be compared to conventional building. That's a conventional building. You can see this is conventional building, someone else's. Here this cantilever also deflected. You see this? Because it's not structural one, it's ordinary one. Brick wall, you can say load bearing wall, and they provided long cantilever here, one more than 2 meters. Result was that this bent. Then the architect proposed these columns to just make it decorative column, but they supported here, which is wrong. It's no more. This happens in conventional building. You can say, what can I do? And then that's why I said conventional building comparison. You can see, it was done. This structure was done in 2009-10. Now a view from distance, you can see this distant view. Let's say here, side track one is just trying to show side of this. You can see this up the way. It's a twisted one because of size of this building like this. Close look, and this internal balcony elevation and LED illumination. You can see how does this strapped windows look like. This is a stair starting from here. I'll show you the basement also. There's no column here. You can see it's connected to, it's hung. This landing is hung. This beam, this hanging landing. And this is the basement portion of stair. Let's see, started steps here. Oh no, this is our entry lounge, internal balcony. Well, I can say here some field sketches I can say here. Also, I like to show here something. This is another case of a facility plant which I'm going to start soon. These some chapters in this. General Industrial Development, Processing Facility, Formation Policy, Decision, Project Design, Control, Hourts, and miscellaneous, etc. etc. in this. These are chapters here. Which I need to save it so that I can start out later on. All of this is saying saved, so I can use it next time. So I thought I had done this all place, and also another one that is also I take print out so that I can show you. That was up, and side start and say start saying something general about that. You know, I just tried to show you what I'm going to discuss in this chapters. Something is old, something is new. It's like that, you know. Both are, you know, I can close it now because it may cause congestion of this. Also it is now, let me close this roll of setting is also close. It's also close, so that at least I can now also just trying to give you something that can be started immediately, that must be taken care of immediately without wasting time. This is another one. This is how we do that. You can see we have to talk of all this in next times. Coming gradually, I'll take up this issue and I'll take up that one. We'll see how it works. This is popular one, so you can say it's so it's also engineering experience. Together same. Let's print off as well. I think one by one I'll show you that, not now all. I must have sketches with me. Sketches are the, for example, these are columns, forms. So okay, it's there. We'll see them too. So we can say we are going to okay, now you can say let's process. I think now we have to move forward. Purpose of this talk was general and it happened. We are moving one direction to the other direction. What I think about quality, can we do something on quality? And that's the point here. How can we move ourselves into a world where we can change something? That's the point you have to understand and to take into consideration. What about quality? How can we define it more in a better way? What better way? That's the point of concern. After all, we're talking of quality. There, plus and plus we can say now, plus and plus it is. We have to be very considerate for that. Thinking and quality everywhere. So this is what some changes to that one. Now quality everywhere, we'll talk. Designs, construction plus plus, you can say quality everywhere plus plus all times. This element quality plus others, construction plus plus, performance, time, cost, risks, reliability, analysis, synthesis, thinking and only way must be contemplation and achieved engineering plus plus. So we can say this addition to previous one, and we must be clear about this. I repeat, I can say, let's see, we're done. And so this way, systems quality plus individual, let us say this way, quality everywhere, systems quality, individual quality, elements quality and others, designs, all stages designs, construction plus plus, construction plus plus, all activities, you can say all activities, other statements, express details, formation, constant unchangeable, cost invariable escalation, risks must be foreseen, reliability plus must be achieved, reliability, safety, serviceability and durability, other knowledgeable areas, factors, analysis, a must, all probables to be understood, synthesis, thing, all solutions network must reach compatibility, thinking and only way, contemplation and must be achieved, applications must be effective, and engineering, this is, you may say, so what to do now? I think you take leave now. It's must. Thank you very much. See you again. Right?